All right, tough spot to be in between hungry people and lunch, but I'll try to make this interesting. Go along this little journey with me that we're going to continue this afternoon. I'll be talking to you about walking, reading, interpreting, and understanding the land, becoming a land doctor. All of us in our ways are land doctors, and I'm putting it in a context that may be a little bit more organized and familiar to you. So we all know what a medical doctor is. You know, they're the people that we go see once in a while. They give us exams, they poke and they prod, they test, they observe, they prescribe, they treat, and every once in a while you might get a phone call and they might follow up with you. They are the people that work on the 11 systems that every human, all 8.2 billion of us and everybody that's gone before have in common. And we know what they are. Most of you have had some form of biology or anatomy. You know, we know there's skeletal systems and circulatory systems and digestive systems. Every person's got those same systems. And so doctors have a common denominator with which they look at, observe, treat their patient. Similarly, the land does as well. And I was young in my career when I read Round River, which is a set of essays by Starker Leopold about his dad. He gathered these essays after his dad had passed, Aldo Leopold, who wrote Sand County Almanac. But in Round River, Leopold was quoted as saying, as one of the penalties of an ecological education is that one lives alone in a world of wounds. Much of the damage inflicted on the land is quite invisible to the layman, and ecologists must either harden their shell and make believe the consequences of science are none of their business, or they must be the doctor who sees the marks of death in a community that believes itself otherwise well and does not want to be told otherwise. Sound familiar? I think we heard that refrain today. When I read that as a very young man, right out of grad school, it might even been during grad school, I thought, you know, what did Leopold mean by that? What did he mean by the doctor? He never really defined it, and sadly he died fighting a fire even before Sand County Almanac was released in the late 1940s on his farm near Baraboo in Wisconsin. I have been able over time to have a relationship with people who knew him well. Buddy Huffaker, who's the executive director for Aldo Leopold Foundation, Kurt Miney, who is his biographer, and the great joy, one of the great joys of my life was working with Estella Leopold, his last living daughter. She sadly passed a year ago, February. So I was able to run some of these ideas by them, so I wasn't operating in a vacuum. I wouldn't presume to know anything more than Leopold knew, but I do want to continue the kinds of things that he was talking about in Sand County Almanac and some of his other writings. So what is a land doctor? Well, we all do the same kinds of things. We examine, we observe, we test, we prescribe, we treat, we follow up. Hopefully we do these kinds of things. As an old NRCS conservationist, it was goals, design, plan, observe, monitor, assume you're wrong, replan. It's kind of the mantra. And in that setting, we do the same kinds of things. We use all 5 of our senses, and we're going to be doing that this afternoon. When we're out on the land, we should be engaging all 5 senses. So when I'm out, yesterday we were out in the field, but at the same time I was hearing the different kinds of birds that were out there. I was hearing the dormant spray machine over the almond orchard next to us. I was seeing different kinds of things on the land. I was seeing some of the insects, some of the pollinators, the domestic pollinators and wild pollinators. Paying attention to what it felt like under my feet. What did it smell like? hacked off a piece of wild radish to see what it tasted like. Kind of woody, but definitely a little bit of a radish. So these are the kinds of things, if you look around these photographs, these are people doing, let's see here. Oops. Let's see here. These are people doing different kinds of observations. Some of them are ranchers. Scott Stone down here on the bottom left, bottom right rather. Guess what he's doing? Ranchers in the audience know what he's doing. He's tearing apart a cow pie to see what kinds of dung beetles are there. So every one of us are land doctors at different levels, and particularly people who are out on the land every day. People who know me know I've got one of my favorite sayings is from a quote from Ernest Hemingway, and he said, "There are no stories inside four walls." And so I challenge people that I work with, people I train, mentor, get out of the four walls, get away from your computer, get out on the land to see what the land's got to say. So, similar to the human body, the Earth, Mother Earth, as I like to refer to her, has got a whole number of systems, processes, cycles. And we're familiar with most of them. We've talked earlier today about the water cycle. We talked about the water cycle. We've talked about different kinds of nutrient cycles. I really like that several of the speakers referred to the biological integrity. And you'll hear us talk about that several times today. Both Alex and I will be talking about biological integrity and some of the indicators of what biological integrity means. We talk about phenology. That was mentioned earlier. Phenology is the time that things happen. And we know that, some of the flowers that and animals that I used to see when I was in my teens and my 20s, for example, the lowland shooting star used to be the flower that I would expect to see first in the springtime, and that generally didn't show up until mid-February to 1st of March. Now I'm seeing them in January, late January. I'm seeing things change on the land. So phenology is changing as the climate is changing. There's other kinds of things, migration and transition, geological erosion, sedimentation, photosynthesis, energy flow, human influences. What's going on, how have humans been influencing not only today, but historically? And how do we look at those, and how do we fold those into being that land doctor? So Leopold was also quoted as saying, "Once you learn to read the land, I have no fear of what you will do to it or with it, and I know many pleasant things it will do with you." Okay? And if you start looking at these different pictures, these are different ways that people are counting birds, doing line point intercept, looking at soil profiles, looking at how to maybe use some different management practices on the land. And then you start looking at what the land is telling us. And there's a vocabulary out there that the land is speaking at all times. And we have to be a little bit wise and a little bit humble at the same time to hear what the land's got to say. What's its message? What's the vocabulary? We know that things like scrub jays, they're animal architects. An animal architect, what the hell are you talking about? An animal architect is something that actually structures habitat. Without scrub jays, our blue oaks are not going to have succession. They're not going to do very well. Why? Because they plant 5,000 to 7,000 acorns every year, and they don't remember where they put them all. So without scrub jays, we're not seeing recruitment in the blue oaks, because some of our past activities, we've removed the brush that they rely on. We've changed the structure of the habitat that they live in so that they can no longer subsist in those areas. So these oak woodlands, without the scrub component, we're not going to see the scrub jays that are those architects that help regenerate those oak woodlands. I really like the idea of thinking about dragonflies and spiders, because they are the invertebrate grizzly bear, and eagle of the invertebrate world. And if they're out there, if we see lots of spider webs, going out on rangelands in the morning, 8, 9 o'clock, right when the sun's coming up, and you can see the dew glistening on the spider webs, and the ground is just covered with spider webs. You just kind of go, thumbs up, things are good out here. And later on, as it warms up, you see the dragonflies, because they are the apex predators of the invertebrate world, and bugs drive the system. If you don't have bugs out there, things are not going to work well, because everything else relies on bugs. It's other bugs, other invertebrates, fish, birds, small mammals, herps, the amphibians and reptiles, and even in the upper Rockies in the middle of summer, black bears are subsidized by miller moth larvae where they can grow up to 40% of their weight in the summertime feeding on miller moth larvae. So without bugs, our world is just not going to be the same way. And even though, we like to see them outside of our house and maybe away from our crops, the fact of the matter is worldwide bug populations are dropping. Anybody who's here from Sacramento Valley or the Central Valley used to drive, when I was a young man, you used to drive across the valley at night, and you'd have to stop once or twice to get your windshield clean. Bugs all over them. Now, try driving across the valley at night. You won't get half a dozen bugs out there. I was just mentioning yesterday in a conversation that in my place in Ukiah, all summer long I left the outside light on just so I could see what kind of bugs would show up. They didn't. We're in trouble. Other kinds of things, we want to look at succession. We want to look at ways that people can do management practices that help heal the earth. And we also need to learn from what past cultures and civilizations have done to the land. There we go. So part of the indicators and diagnostics that I use, and kind of in this spirit of being land doctors, using some medical terms, indicators and diagnostics, you want to look to see what's going on the land, and look to see, how Native Americans utilize the landscape. And for those who have done conservation projects, we always have to bring the arcs out. Native Americans have a saying about that. They say, the arcs cared more about us now than they did when we were alive, kind of thing. So it's one of those things where it's a necessary evil to get the arcs out there to kind of show us where these cultural sites were. In California, we have a number of those areas. Every county basically is full of archaeological sites. Natives don't call them that. They call them, sites where we lived, where we made our living. And almost always, if you're going to do a project in and around a wetland area or water area, those are areas where those civilizations spent a lot of time. So you're going to see evidence of Native Americans in and around water areas. If you see, fields of camas or soaproot, you can bet that those were cultivated by native people. They actually, it was one of the crops that they utilized. We also know that in California, they were a basketry culture, that they needed somewhere between 7,000 and 15,000 individual pieces of plant material per basket. But the killer was they couldn't have a node. So it all had to be first-year growth. Imagine a family needed somewhere between 15 and 30 baskets a year. Do the math on that. Try to go out and find 7,000 pieces of plant material today that don't have nodes. It's almost impossible. So they extensively managed the landscape, and the evidence of how they managed the landscape for those cultural and basketry and other kinds of domestic needs are really out there in the land if you know what you're looking for. Other things like timber harvest, mining impacts, we can tell what kind of historical livestock grazing has gone out there. How do we tell the difference between what's historically done with sheep and cattle? Well, we look at the fence. See the old hog wire out there? We know pretty much that was very likely a sheep operation. We look at the terracettes. What's the difference between the terracettes on the hillside? Are they tight together? Well, it's probably a sheep operation. Are they fairly wide apart? Probably a cattle operation. So there's these things out there, there's indicators on the landscape that we can look at. And then there's all kinds of diagnostics, and I've kind of broken these down by soil, water, air, plants, animals. But we start looking at, is there a formation of O1 and O2 horizon? That's the organic layer on the top. O1 horizon, we'll be looking at that this afternoon, see if we can see that. O1 is plant material that you can probably identify. O2 is kind of humus. You can't identify that horizon. I call dreadlock roots. When you pull up the plant, is soil adhering to the roots? Are the plants leaking sugars so that the microbes can be fed? Or in the case of, too much use of Roundup, you pull them up and the plants are just, the roots are white or pink and there's nothing adhering to them. That the soil microbes have taken a hit because of the herbicides that are utilized. Is there structure out there? What kind of structure? Is it platy, subangular, blocky, or is it massive? Have we been beating the soil up so much that it doesn't even have structure? Is there any kind of evidence for soil sequestering carbon? And I mentioned those dreadlock roots. That's a real good evidence that the plant is making sugar that's leaking out, that's feeding the microbes. Evidence of compaction. What are the water flow patterns? Soil color, all those things matter. In California, particularly in our valleys, dust is a big issue. Do we minimize dust, smoke, exhaust, agriculture odors, burning? Can we maximize vegetation in and around farmscapes that will ameliorate some of the impacts of dust? Vineyards and orchards. Air particulate matter from livestock operations are taken care of. It doesn't get into the air and something all the rest of us have to breathe. Do we enable optimum photosynthesis? And we're going to talk a little bit more about that this afternoon. I know Alex has got some thoughts about that, but photosynthesis is not photosynthesis. What do I mean by that? I mean that photosynthesis, one of the measures is Brix. So if a plant, and Brix is a measure of sugar in the plant. So if the plant is struggling, it's having to compete for air, water, nutrients, it might be a Brix of maybe 3 or 4%. But if that plant's got all the water, the nutrients, the space, the air it needs, you might have Brixes north of 15, 20%. So what would you rather have out there? These plants that are really kicking tail and producing a lot of sugars, taking a lot of carbon dioxide and turning it into air and sugar, or you want them limping along, and as Alex talked about, the green's not there. So we really want a lot is green growth out there. What kind of green growth do we have? Okay. Lichens and mosses are indicators of air quality. If you see the lace lichen on these trees out on our rangelands, that's a symbol of good air quality. And the cool thing about lace lichen is that they actually filter particulate matter in the air, and when you get the first rains, that particulate matter, which are often nutrients, are made available to the tree. So there's a symbiotic relationship there between the lace lichen and the tree. There's a lot of indicators. I'm not going to go through all of these, but you can kind of read them. We can see if plant succession's out there, as monocultural crops are minimized. We try to control our invasive and noxious weeds. We have a representative group of plant functional groups. That means, the annual grasses, the perennial grasses, the warm season perennial grasses, ferns, sedges, rushes, trees, moss, so on. Those are the functional groups. Many of our communities now have been simplified. We're the ferns. We're the sedges. We're our multiple age classes of brush. We're the multiple age classes of trees. What's the land telling us? What's keeping that from happening? Nodules yesterday on the legumes. We're looking at the legumes. You pull up the legume. What do the nodules look like? Are they black? Are they brown? That means that they're not really making nitrogen. Are they white, which we saw yesterday with a slight pink? That means that they're producing some nitrogen, but not really as well as we'd like to see. Are they pink? Pink means that they're kicking tail, that they're really producing a lot of good nitrogen and making that available in the soil. Other kinds of things, water infiltration occurs at expected rates. Runoff's mostly clear. Our waterways are vegetated. Our water has the invertebrates in it that have the Isaac Walton League calls type 1, type 2 invertebrates. So we know that if you go to the high mountain streams, you see what we call EPTs, the Ephemeroptera, Trichoptera, Plecopterans, with stoneflies, caddisflies, mayflies. That means you've got some really good water quality, and I'll probably drink that water anytime, unless there's a beaver dam above it. But if you start getting lower and you start seeing things like dragonfly larvae, they can tolerate poorer water quality, or you get into water that's got leeches or other kinds of invertebrates that can live in any kind of water. Those invertebrates are telling you by their presence or absence what that water quality is. You don't even have to run it through some sort of lab test. The animals will tell you what's there. Getting into the wildlife, we talked a little bit about the damselflies, presence, absence of beneficial insects, abundance and diversity of native pollinating bees. We know in California we've got about 12,000 native pollinating bees. About 70% are solitary ground nesters. Well, most of us don't even see them because they're small, but they can be as large as bumblebees. So we've got those pollinators out there that we have a responsibility for making sure there's nectar and pollen resources for them. Looking at streams, do we have habitat in the streams? We worry about habitat, in our terrestrial habitat, loafing, resting, roosting, escape, nest cover. So like all of us, animals have to have their requirements. We've got our bathrooms in our house, and our kitchen in our house, our living room, our bedroom. So there's different places that we can live out different parts of our life history. It's the same with animals. Are those present or absent? It's the same in the stream column. Are there root wads? Are there vegetative mats? Are there rocks? Are there gravel? Are there overhanging banks? Are there boulders? What kind of structures in the creek? So once we diagnose, what sort of maladies there are on the land, they have what I call, the pharmacy. And the pharmacy, being an old NRCS employee, my pharmacy is the 170 some odd practice standards that are available in the Conservation Planning Procedures Handbook. And those practices are broken up into 3 broad categories. They're management practices like prescribed grazing or irrigation water management, upland wildlife habitat management, or, help me out here. Or they're facilitating practices where they facilitate conservation. So if we want to facilitate prescribed grazing as a management practice, likely we're going to need fence, we're going to need water developments, we're going to need access roads, those kinds of practices. But if we really want to get things moving, we do what's called accelerating practices. So maybe we plant some rangeland, or maybe we do some prescribed fire, or do some brush management, okay? So those practices can be found in online. Like I say, there's about 170 of those practice standards. Here's a couple of examples of some buffers and some hedgerow practices. And I've got that embedded in here, but for the most part, if you look under NRCS practice standards, it comes right up, and you can look at the individual practice standards and specifications, so that pharmacy then becomes available to you to be able to make some choices about how we move land that's not currently in good health to health. And again, we're going to be talking about this a lot this afternoon. I was going to talk a little bit about monitoring, but I think I'll pass that up and leave some time for a question or two. No questions?
What types of soil testing we could consider just as small producers or things like that. What, and I'm trying to sort out Hanley versus more standard ones. There's just different flavors of this thing without having a lot of knowledge of it. How do you choose?
Great. Good question. Some of the tests that we use are for soil aggregate stability, which we're going to look at this afternoon. Do the soil aggregates hold together? Do they have the slimes, the mosses, the kinds of things in there that hold, do a good job of holding soil together? So you take a piece of soil about the size of a pea, you put it in your water bottle cap, pour a little water over it, and see what it does for 5 minutes. If it's flat at the bottom of your bottle cap at the end of 5 minutes, you got really poor aggregate stability. If you shake it around and that pebble, that pea-sized piece is still there, your aggregate stability is in good shape. So that speaks to what kind of invertebrates, what sort of biodiversity you have in the soil. As it's known, edaphic flora and fauna. It's a fancy way of saying your soil animals and plants. Another thing we like to use is looking at water infiltration, where you take a ring of a known area, you pour water in and measure how long it takes to infiltrate. And after 2 hours, we stop keeping time if it's that compacted. There's some other soil things that we can do fairly easily, like soil bulk density, which is a measure of compaction. You can take a measure of soil, put it at 100 degrees for 24 hours, and then weigh it before and after, and it gives you a percent of bulk density. The higher the number, the less bulk, less compacted it is. The lower number, the more compacted it is. So there's some kind of simple things that you can utilize. I always like to look at structure. I like to look at color. As I mentioned a little bit earlier, color tells you a lot. The darker the color, probably the more organic matter. The redder, the more highly leached. The whiter soils are probably organic matter deficient. So you can kind of look at those. You can look at what kind of structure's out there. So there's a lot of different things that a layperson can do without a lot of lab equipment that give you great information about where your soil is. Walking on it, what's it feel like? Do you pay attention when you're walking out there? What's it feel like? Okay. Other questions?
Thank you, Wendell. That was great. I have a question. You mentioned that there are landscapes that have issues with recruitment of younger or maybe multiple generations of woody species, trees, shrubs. When you see that, what are some of the questions that go through your mind? And
when I look at a vegetative community that doesn't have the kind of structure, doesn't have the kind of age classes that I'm looking for, doesn't have the kind of diversity, then I start looking at historical land use. What's gone on here? And in California, on our rangelands in particular, there's something that we have termed cow pie, okay, or I'm blanking here. Anyway, it's a cow pan, and it's been created by livestock that are out on the land at exactly the wrong time for the soil. But there's not a lot we can do about it because that's when there's water and that's when there's green grass. But if you think about these big-bodied animals, anybody here been stepped on by a cow or a horse or sheep? Yeah. So you got big-bodied animals that have really small feet relative to their size, and every time they take a step, somewhere between 400 and 600 pounds per square inch is applied to the land. Well, if we want to build a reservoir, if we want to compact something, what do? We put some water on it, we do a lift of maybe an inch or two of soil, and then we put a sheep's foot on it. So that's how we make our dams and our reservoirs, earthen dams, is that compaction. So we've applied this compaction in California for over 300 years now, and we've created what, unfortunately, are sheds. We create sheds, and what we really need are catchments. Instead of water sheds, we want catchments that hold, store, slowly release the water so we can reintroduce the sponge, which we've lost to the tabletop. And if you start looking at streams, and we'll look at this afternoon, if we start looking at streams, the land is actively resolving the hydrologic issue of runoff that's very flashy. As soon as it rains, it runs off. As soon as it rains, it runs off. Instead of, if it rains, it's kind of got a slow hydrographic curve or a hydrologic curve, and it slowly releases and slowly infiltrates into the soil. But if you look at our streams, they're continuing to adjust to this new hydrologic reality. They're incising, they're downcutting, they're dewatering shallow aquifers. And a lot of the work that people are doing now is trying to return the functionality of those streams to what they once were, get them back into the floodplains and do the kinds of riparian work to hold the water, store the water, slowly release the water. And that begins in the upper watershed. That begins with the management in the upper watershed. Okay? Answer your question?
Yeah, I'd like to thank Wendell Gilgert for coming out today. He'll be available during the Vina Plains leading with Alejandro. So thank you.